exclusive. What do you notice about the not? Oh, you can't even see what I was drawing. What do you notice about the mutually exclusive Venn diagrams? What do you notice the difference is? Mutually exclusive and not mutually exclusive. Guess what that is? It's A and B, right? Which, according to our equation right here, PU probability of P and half be in a degree, and let's just do A and B. It would be probability A plus probability of B minus probability of A and B, right? You got to subtract out that part right there. Because when you count up A, you already counted up everything that was also A and B. Then when you counted up B, this is A, right? A, that's B. You already counted up those that are A and B. So we just got to subtract the ones that are A and B. All right, we're almost there. So while we're on the topic of mutually exclusive, I thought it would be a good idea to just review some very basic Venn diagram stuff. So you get your circles, and notice that these particular circles are this circle on the left is
blue.
Blue.
Square.
And the one on the right is for squares. So let's count up how many blue we have. We have 1, 2, 3, 4, 5, 6. We got 6 blues. Now let's count up how many squares we have. We have 1, 2, 3, 4. We got 4. So that means if we're going to do a union here, the B union, or we could say or, right? B or S, right? Then we should just add them up, right? Add them up. If they were mutually exclusive, but they're not. If they're not, notice that B plus S is 10. But they're not mutually exclusive. They're not mutually exclusive because they have blue.
Square.
Squares. They're both blue and they are square. So if we look at what we're talking about here, then B and S is equal to the squares in there. So let's just call that. So, remember the rule, B plus S, and then take away the end part. And then see, this makes sense, 7. There are 7 objects total. Because we'd already double counted the ends in there. That's how we ended up with a 10, and then we took away their intersection. And we have, again, our union rule for non-mutually exclusive situations. So let me bring up what we're looking at here. See this one, agree and don't agree. Remember, you can only choose agree, don't know, or disagree. So you can't choose agree and don't know at the same time, right? Not in math, anyway. I suppose everybody's, hey, can I put like a hat? I don't know. Anyway, we get the idea. This is the one we're going for. Notice this is whenever they're not mutually exclusive. That's how you find a union. You've got to take out that middle part in the Venn diagram, right? You got to take out the middle part in the Venn diagram. Mutually exclusive would be a Venn diagram. Like that right there. And then we always put the U for the universe. Oops. That's mutually exclusive. Not mutually exclusive would be, sorry, I gotta watch that the dog doesn't come over here and eat my pen. Oh, yeah, I knew it was gonna happen. I knew it was gonna happen. He was sneaking it. Anyway, not would be where they have this intersection. So you had the A, you got the B, and right in here is A intersecting B, where, like we had in our Venn diagram up here, the intersection was that the intersection A and B square and blue. Right. We still have A. We have B, which is what we need. We're almost there. We're wrapping it up. This has been a whirlwind because we're trying to get all this together. Mutually exclusive defined. Mutually exclusive defined right here. Any questions on mutually exclusive? And you can type them in the chat. Let me check. Any questions on mutually? We did two-way tables before. Remember way back in week 1 activity, 2-1, and we also in the week 1 assignments. Here's your probability of the OR rule, the thing I just put out there. I just want to grab the paper. The thing I just put out, you subtract the part in the middle, which is A and B, right? So when A or B is 0, they are mutually exclusive. Because there is no A and B, it's 0, right?
Blue.
All right. So that's it. That's the deal on that. I'll do something with I'll do something with sampling with and without replacement. If that shows up in the homework, I gotta double check. It might be in the next one. So here we go. We got this. We're good to go.